Saxon Algebra 1, Lesson 55. I hope you're ready to feel smart today because our lesson is not horribly difficult, but it looks super fancy, and most students find this to be not only rewarding but very satisfying. Well, I guess that means the same thing. It's fun because look, we're going to do something that looks really, really hard, but is not difficult to do. Trust me. We're going to resolve what are called complex fractions. What makes a complex fraction is that it's a fraction, duh, that has multiple what we call division bars, okay? It's got more than one, and you know, that's cool, but we want to simplify this down so there's just one division bar. Notice how I've exaggerated. This one is smaller and this one's bigger. That's really important. The division bars are never the same size. And you can see that in the overall fraction, this is the numerator and this is the denominator. So in John's, you can usually tell because he makes this one maybe a little darker. His aren't as exaggerated as mine. Make sure that you develop the habit in your homework of making it really clear which one is the bigger bar, okay? Otherwise, you'll get yourself hopelessly confused. And, you know, I can't have that. That just keeps me up at night to think my students are confused. I can't live with that. Okay, so what we do when we are faced with a dilemma such as this is we send all of our attention to the denominator. We look at the overall fraction and the denominator, and later we're going to get even more complicated denominators, but we look for the basement of the basement, right? We look for the lowest part. And the reason we do that is because we're interested in the bottom, because we know that anytime you have a fraction over 1, you can knock out the denominator, right? Anything over 1, you can just ignore that denominator. So what we want to do in these problems is we want to turn our denominators into 1s, okay? So that's number one thing. Turn denominator, I'm not going to write it all out, into a 1. That's our first goal. The way that we will do that is to use a reciprocal. That's the tool we use to turn whatever's in the denominator into a 1. Now, we know that reciprocals are just flipping it upside down, right? Whatever is in your fraction, you flip it. And the cool thing about it is that when you multiply them through and simplify, it'll always equal 1. Yay, we'll have turned it into a 1. Now, C doesn't look very much like a fraction, so how do I find the reciprocal of C? Oh yeah, put it over a 1. So we want to multiply this by 1 over C. Don't let the fact that these are letters rattle you. It's actually easier when they're letters because they don't actually do all that much, right? They just kind of sit there and be lettery. You don't have to figure out what, 42 times 15 is or something like that. Okay, so our goal is to turn that C into a 1. The way that we do that is by using a reciprocal. This now multiplies through. You don't normally have to show this, but I want to show you. C times 1 is C. 1 times C is C. C over C equals 1. And look, now the whole thing can just go poof and it's gone. However, we did something right here. I want to put that multiplication dot where you can see it. We multiplied the bottom of this fraction by 1 over C. If we're going to keep this thing in balance, one of the main rules of algebra, there's 3 rules to algebra, and this is one of them. If you multiply the denominator by something, that's fine, but you have to do the top as well. And you know that. You've been doing that ever since we started adjusting the denominators of fractions, right, so we could add them. You know that. You've been doing it a million times. Hannah Cranny insists on it. Have I told you about Hannah Cranny? I hope so. Pretty sure Caleb has heard. I don't know, Jackson, if you've heard that story. She's a former student of mine. So I'll ask you in your video chat if you've heard it rather than subject you to it yourself right now. Okay, so this has all gone away. We're happy, but denominator, numerator, same quantity rule insists that we multiply the top by the same thing. And so we get A over B, C, and guess what? That is our final answer. Yay. Okay, so we use these two they're not like steps, but they're like plot points, right? Our goal is to turn the denominator into a 1, and we're going to use the reciprocal as the tool to get that 1. All right? Let's try another one. Straighten up my book. Example 55.2. Simplify, right? Now, I'm going to tell you one other thing that John puts in these problems. Okay, there's the problem. In the book, this one isn't that much longer, but it's darker. I make mine longer, so it's easy to tell. And then John also writes this. What John's telling us here, oh, I wrote the problem wrong, just a second. I'll just leave it like this. What John's telling us is these two letters are not equal to 0. Why is that important? Because if these were 0, we would have to worry about blowing up the universe, right? Imploding the kingdom. Because we could not end up with we couldn't even have here a fraction with, if this was 1 over 0, game over. We can't do it. So he's just given us a little, don't worry, I'm not going to blow up your universe help right here. And we thank him for that. Now, I copied this wrong out of the book. It should be C on the top and B on the bottom. I'm just going to leave it like this so I don't confuse you. But if you look in the book, you'll see it's different. We'll make sure we do it right for this way. But it's easier than, I'll just work it this way. Okay, our goal is to turn the denominator into a 1. We do that by multiplying by the reciprocal. The reciprocal of this denominator fraction is C over 1. I'm going to write it right here, right now, because I have to remember to do that. Numerator, denominator, same quantity rule. One of the 3 major rules of algebra. This turns into a 1. I'm not even going to show it. I'm just going to slash it to show that we're done with it. And our final answer is C over B. And that is the right answer for how I wrote the problem. Third example, A over 1 over C. And again, John helps us out by saying C is not equal to 0. He helped us in the first problem too. I just didn't want to mention it because there was enough going on the first time through, right? I have to annoy you with details in a step-by-step manner, because if I give you all the annoying details at once, you will throw your viewing device to the floor and run screaming from the room, and I'll have to explain to your mother why I made you so angry. So I give it to you in bite-sized bits. All right, this one is different. I mean, they're all a little different, but we use the very same strategies. We find the denominator, look in the basement. We think, how are we going to turn that into a 1? How can we use a reciprocal? Oh, okay, C over 1 will do it, right? Same up here on the top, right? This all goes away, turns into a 1, I should say. It goes away because it turns into a 1. And now we have this on top. Now, this looks a little bit confusing. So what I'm going to do is I'm going to rewrite this down here. You don't have to do this, but I just want you to see. It's A times C over 1. Sometimes it helps if we do that. Like I could do like that if I wanted, just to help myself see what I'm doing. C with my eyeballs, not C with the letter C. All right, so whatever it takes, but our final answer here is A times C. These problems are also fairly satisfying because they smoosh down to such cute little answers. We have one more, and this one's harder, so, get ready. Top fraction, big line, bottom fraction. What the heck is that? What is this, John? What is this? Well, feel free to express your shock and outrage at John. I have no problem if you yell at him. I have no problem if you yell at me when you're doing your homework, for that matter. Feel free to burn off your emotion by, telling me off if that's what it takes. But come back to earth and let me tell you, this isn't very hard. The strategy is exactly the same. We just have to flip it, right? So we're going to multiply it by a plus x over b. Look what happens when we multiply those. We get b times the quantity a plus x over a plus x times b. I just left them in that order. This is exactly the same. That cancels out, and we get 1. Yay. You don't have to show that, but if it gives you any kind of pleasure to do that, which it kind of satisfies me, I think it's kind of fun, you can show this. For me, I'm fine if you just show that much and then go, peace out, dog. But before you slash it out, make sure you have copied up to the top whatever you multiplied it by, because you have to do top and bottom. Sometimes it's helpful to do this to make sure you're remembering to multiply top and bottom by that adjusting thing that you chose. All right, that's what we did when we first started learning how to convert fractions, right? I would do that kooky one thing. Caleb, you remember, don't you? And I told you about how some students thought I was drawing an Abraham Lincoln stovepipe hat. Oh, the memories, the memories. Okay, so now this is all gone. This we're multiplying. So we get a times the quantity, a plus x, over, I'm going to go alphabetical here, bx. This, let's see if this is our answer. Maybe John distributed that, but I'm going to check before I distribute it. Nope, he left it just like this. So we're done. Yay! All right. And John does a little bit of rehash just to remind you that there's an important rule of algebra. And I already talked about that. Okay, we're done. Yay! Lesson 55 is history. We're going to do a lot more with these, you guys. We're going to make them bigger and badder than your imagination can probably even fathom right now. So, don't panic. Most students find these pretty manageable and feel quite tickled with themselves when they are killer complex fraction simplifiers, because it's kind of satisfying. All right, I'm done. Lesson 56 beckons you next. Goodbye.